Hey everyone, welcome back to my YouTube channel. Today I'm going to show you a YouTube listen along feature that I built using Supabase Realtime. So this is a feature of Spotify listen along. It's on their paid plan where you can start or join a jam where anyone can queue the audios. So let's see how this works. It just needs a room name and I'll just enter same name in both the browser window, and let me grab a YouTube link from here. Let's grab this and just queue it. So you see both get queued, and as soon as the leader will click on this, it will start playing and both the browser window is now playing. Alright, let's see how this works. So let me just zoom in a bit and let me. Alright, user lands on this page, which is listen along, the root page, and then we show an input for setting up the room name or joining an existing room, which is just similar to how Shopify does, like joining a jam or creating a jam. So as soon as user hits a name, we just redirect it to listen/room name. As soon as this gets hits, this Next.js dynamic endpoint gets called with a room param, and we pass in the room param to this listen room component. So what this component does is it basically handles all of the things, which is playback, drifting, Supabase, logic, and each and everything related to listen along. So let's see how this works. So initially we set the identity of user, like who the current user is. So this we just create a key, random key, and then assign a random name and then save it to the local storage so that if user refreshes, then also the session persists, like the name and all persist. So then we define some states that will help us to manage the room audio and video, like audio players and all YouTube player. And then there is a concept of leader, if the user is leader or not. This is basically defined by any user which has the lowest ID is the leader. And then there are some helper methods. Let me take you directly to the Supabase logic of how things work. So let's see, whenever user hits a name in the room, what happens? So as soon as this gets redirected, we get the room name, then the use effect will load the YouTube player. So what we does it, we basically have an iframe which is of height and width 0 so that we can play the YouTube video, and we do not show that video to the user, we just play the sound. So these are the methods that basically check if the YouTube video have ended or not, because once the video ends, we have to play the next track in the queue if there is any, or if there is no, then we have to pause, or we have to like just stop the playback. So this is the Supabase method of creating a channel. So in real time, we have to create a channel, then we have to broadcast events, and subscriber can listen to that events and react on whatever data we have sent in it. So let me just show you the presence one. So what this does is, this is basically used to show how many users are connected to this channel. So this is an internal event that Supabase itself give presence, and with this we get the data, like channel.presence state is a Supabase method which basically gives us what all listeners are connected. We see how many listeners are connected and then set the listeners. So whenever anyone subscribe, like this is the main part which subscribe to the channel. Whenever this is done, we set the connected state, and then if the status is subscribed, and then we send a sync request. So this send is basically broadcasting the events to everyone, like broadcast, event name, and then the payload that we have to send. So this will send the sync request with this payload, which is the current user ID. So sync request will come in all the subscribers, and as soon as this lands in, this callback will be called, and we check if this is a leader or not. We extract the current queue, and then we send the complete queue with the current index, and then we play the broadcast after 150 ms. So we give it some time to settle it down, and then what this does is this basically send another event which is of playback, which tells what song is playing right now in the queue, what second is the song right now, because there can be instances where, let's say, I'm listening to something and 20 seconds have already elapsed. The second user whom I share the listen along should be joining from the 20 seconds, else there will be a 20-second lag. So to maintain this, we have to send the seconds, the current playback seconds which is there, and then we have to send if the audio is playing or not, and then the current timestamp. So this is the epoch timestamp which will help us to calculate the drift. Let me show you with the help of an example. So let's say this is user 1, And wait, currently this one joins a channel. The channel will be, the channel name is wait, let me grab it, listen, and then the name of room. So the channel name will be listen dk. And then this subscribe to the real-time events. Now we can queue a video. Let's say user have queued 3 videos, video 1, video 2, and video 3. Let's say this video is playing right now. Video 1 is current track, and t is equal to 20. So basically this has already been done. Let's say I'm playing audio and 20 seconds have already elapsed. Then a second user joins, user 2. The current track is same. As soon as this joins, a presence event will be fired, then sync request will be fired, then payload. With the sync request, we will with this sync request we will send the playback event, and as soon as this playback event gets sent, this callback method will be called. And what this does is this sets the audio to be starting from 20 seconds, so that there is minimal drift. So there always will be minor drift of latency and all, which comes out with network latency, which we cannot do much about it. But again, we can just calculate the speed. Like, there can be ways to optimize it. We can calculate the speed of network, check the latency, and then calculate the drift. Like, assume that drift can be this, and then set the current seconds. But let's not make it complicated. Let me just copy this also, and they have also joined the same room. So let me just keep it here. All right. So we have sent all the data. Like this is all the data we have sent. Index, which is the current video that is playing, the seconds, which is t equal to 20, playing if the video is playing or not, if the video is paused, and at is the current epoch time. So once we apply the playback, we check if the current player is playing or not, because this is getting broadcast to all the subscriber. The current window session will also be subscribed to it, and will also get the event. But we will check if playback, like if player is already playing, then we won't react to it. If it is not, then we assume it is a new window session. We set the index in the queue, because we already have the queue from the sync request. Like, first sync request will go in. With the sync request, we send the queue. With this queue, the current browser window will have the queue, and then after 150 ms, this will send the playback event. Once this happens, we set the index, the current video which is playing, which is video 1, and then if the video is playing or not, and then we get the track. If we do not have the track, we just return. If we have the track, we calculate the drift, which is from the current playing, like the player timestamp, and then the current date, like current epoch timestamp minus the timestamp in which playback was called. We calculate the drift, we calculate the seconds, and then we load the YouTube video from that second. So if, let's say, loaded ID, we get the data, we get the video data from the video ID. And if the video ID is not equal to track.video ID, the current track which is playing on, then we seek the audio. Like, this is a new player, we seek to the current seconds that we have calculated, and then we just play the video. So at that time, the audio will start to be playing, else we just pause it if the playing is false. And then let's say if this is already being initialized but it was paused or something else, we just load the video, we just queue video by ID. Now we have seen the playback. And then let's say whenever anyone on the channel queues a new video, we set the queue, we set the index with the broadcast. Like, as soon, like, wait, let me show you what happens when anyone queue the music. So this is adding the track. So we get the video ID, pass the video ID, attach it to the current queue, and then set the current browser session queue, and then broadcast the event with the complete queue. As soon as we does this method gets called, and what this method does, it again call the send method, which broadcasts the event with queue and this payload, the current complete queue and the index. And this gets land in here, and then which sends the set the local queue, set the index, and then the UI responds to it. And then again, same goes with removing the track. It just remove the track from the queue and then broadcast the complete queue. So that's it. Then this is UI component basic, showing how what all tracks are there. We can also show the current timestamp. Like, there can be a lot of things that can be done, but we are not doing it right now. We are like showing thumbnail. Like, it can be enhanced, but this video is not for that. This is just for showing you how powerful Supabase Realtime is, and how you can use it to create something fun or something. Like, just think of it, how you can maybe create a Figma for AI agents, which basically 3 different AI agents are there on a Figma screen. They are brainstorming, they are creating UI, and then the designer gets feedback from a manager agent, and that on real time changes the Figma design. Then the developer takes a screenshot, send it to the agent, and then agent respond with whatever changes needs to be there. So you can like it opens a lot of things which is very easy to handle, because again Supabase removes all the complexity of Elixir, knowing Elixir Phoenix. So I hope you like the video. If you like it, just hit the like button and hit the subscribe button, and I will add all of these in a GitHub repository so that you can just take a look at it and can just play along with it. So that's it.